our last section in this module is 1.8, and 1.8 is simplifying expressions. And to identify terms, like terms and unlike terms is what we're going to do first. A term is a number, a variable, or a product of numbers of variables. Let's look at some examples. It could be just a number, it can be a variable, or it can be a product of numbers and variables. These are all terms. -2 is a term, x is a term, 3x is a term. I can say -4x is a term. It doesn't matter if it's negative or if it's positive. It just needs to be at least a variable, a number, or both of them together, a product. The next thing we're going to talk about is numerical coefficient. This is the number factor of the term. So on this first one, the numerical coefficient of -2 is -2. The numerical coefficient of x is 1 because there's an understood 1 in front of that x. The numerical coefficient of 3x is 3. And the numerical coefficient of -4x is -4. So it's either going to be the number in front of the variable or the number itself if it's just a number by itself. And if it is a number by itself, like this one was, -2, this is actually called a constant. A constant is a term that only has a number. It does not have a variable. Okay, so the constant does not have a variable. It is just a number. Now let's look at another thing we're going to talk about, like terms. Now, like terms are variables, are terms that have the same variables raised to the same exponents. So let's look at some like terms. Like terms have to have the same variables raised to the same exponents. So I can have, we'll use the ones up here, 3x and -4x. These are like terms. If I had 5xy and 6yx, even though the xy is first and the yx is second, these are like terms because they both have x to the first power and they both have y to the first power. Like terms definition does not tell us about an order. It just says it has to have the exact same exponents or variables raised to the exact same exponents. So you're just looking for the same letters raised to the same exponents. So let's look at -2x squared y and 4x squared y. These are like terms also because they both have x to the second power and they both have y to the first power. So these are like terms as well. So let's look again at our like terms definition. It has to have the same variables raised to the same powers. So let's look at some examples of unlike terms. Unlike terms are examples like this, 2xy and 5y. They're not like terms because they both don't have x to the first power. They both have y to the first power, but they both do not have x. So these are not like terms. Some other unlike terms would be 6x squared and 8x. They both have an x, but it's not to the same power. So these are examples of unlike terms. Now, why is it important for us to learn what like terms and unlike terms are? You can only add or subtract like terms. So if they're not like, just like we had in our last section when I said it was in simplest form, that's because we did not have any like terms. So you can only add or subtract like terms. Now we're fixing to get into some examples where we're actually going to be combining like terms. And remember, terms that are like can be combined, added or subtracted. If they're unlike, they cannot be added or subtracted, and it will be in simplest form. So let's just do our first example. And it says 9y minus 4y. Now, we talked about numerical coefficients. The numerical coefficient is the number in front of the variables. We are going to use sign rules for the number, and the y is just going to be dragged behind it, kind of like a suitcase that's just rolling behind you. You're not changing the suitcase. You're just carrying along for the ride. So 9 minus 4. I have different signs, so I'm going to subtract. 9 minus 4 is 5. And take the sign of the bigger number. The bigger number is positive, so my answer is positive. Don't forget your y. Now, why could I do this? Because they are like terms. So you always want to make sure that they're like terms first, and if they are, then work the problem according to your sign rules. So let's look at number 2. X to the second, x to the second. They're like terms. So let's look at the numerical coefficients, or the numbers in front of the variables. I have an 11 and an understood 1. Remember, this is a 1. So 11 plus 1 will give me 12, and the x squared just comes over. So remember, as long as you have like terms, you can proceed. Let's look at number 3. I have a y, an x, and an x. Well, the x's are like, but the y is not. Now, if it's in simplest form, that particular number, you can go ahead and bring it over into your answer. I'm not going to be able to change 5y because there's nothing that I can combine to it. So it's just going to come over my answer. I can, however, combine the x's. So I have a -3 and a +6. Different signs, so I'm going to subtract, take the sign of the bigger number. The bigger number is positive, so my answer is going to be positive, and it's going to be a +3x. Now, why is it a +3? Because when I subtract 6 minus 3, I get 3. The bigger number was positive, so my answer was positive, and the x just comes along for the ride. Okay, I'm going to stop it here and pick up on number 4 in the next video.